Hello, my name is Lindsay Shuck. Thank you for joining today's Family Office Network's webinar series featuring Pattern Computer. I would like to introduce our speaker today, Mark Anderson. Mark is a well-known predictions expert focusing on the intersection of technology and the global economy by discovering pattern in world events. Using a similar method to his predictions, Mark developed the idea of a brand new way of computing and processing complex data sets with the discovery of patterns without using theories. These new pattern discoveries will change the way industries attack problems. At the end of today's presentation, we will have time for Q&A. We encourage you to send your questions over at any point during the webinar using your questions chat option.
Thank you, Lindsay. It's great to be with all of you. I'm looking forward to this. I hope you are. The way I'd like to talk about our discoveries and our experience is to have a conversation as though we're going on this journey together. This has certainly been a journey for me and for all of our team, and so we'd like to have you be part of that journey. It's the excitement level is a little bit hard to describe unless you're living it, but I'll try my best to share it with you by showing you some of the discoveries that we've made. And one way of expressing this is I'm known for various things, one of which recently appears to be that Elon Musk flew up to see me to talk about when he was going to start SpaceX and how excited he was. And I can tell you, as excited as I am for Elon doing SpaceX, I think that what we're doing with Pattern is bigger. That's a big claim. And so part of my job today is to share proof of those claims to you so that you have that same sense of achievement and excitement. We'll just do a couple of quick jumps here through what we're doing, and I'll avoid being too technical. We've reserved a lot of time at the end for Q&A, so for those of you who are technical, happy to answer your questions. Here's a simple diagram that should help you see what we're up to. And if you start with the very basic idea that we're not doing what you normally would think of if you have heard of AI before. We've built a system, both software and hardware, mostly software, that does things very differently from today's neural networks. And because it's different and because it's better, it allows us to see things that others can't see. So when we say for the world, this is an impact investment. You want to change the world? You want to change things? What if you could have a system that found answers and solutions that were unavailable until now? No matter who we're talking about, no matter what field we're talking about. And so for the customer, the obvious benefits are right there. What's your biggest problem? Go to any customer. Imagine if you can go to any customer, whether it's a scientist or a Fortune 50 company, and say, give me your biggest problem that your guys can't solve. We'll solve that for you pretty quickly. One of the secrets to this is, unlike how scientists and business data scientists work today, we don't have a hypothesis in mind. We have an extremely capable system which brings us all of the patterns in that data without any hunch, without any hypothesis. And the result is we see many things in more detail than those people who had been working on it until now. Here's another simple picture. What really matters here is this quote, the most advanced machine learning company on the planet. This is an expert from Lawrence Berkeley Labs who was talking to the head of AI at the Department of Energy this last summer. And he's describing pattern computer. So we've been looked at by a lot of well-known people who are real experts. And I'll give you one more example. Lee Hood, who invented genome decoding, said that pattern computing is the critical piece for moving forward with medicine. So clearly we have found something which is catching the attention of people who are experts in their own way, and we're all excited about the same thing, which is being able to see more details in higher resolution, more complex answers than just one or two things. Now you'd ask yourself, how would you do that? What kind of team would you have to have? And of course, you'd have to have a world-class team. Now, these are just a few of the people who helped start the company. We have about 27 now headcount in full-time and part-time employees, and they're all amazingly brilliant. I just want to mention a few here. Ty Carlson, who started at Microsoft, was there for about 20 years, I think, worked on all the operating systems, and then Office 365, scaling it up to enterprise, left there, went to Amazon, and he was running their most important product then, which was Alexa. He was a senior technical lead there, and he left that to join us as the fourth partner in our co-founder team. Mike Riddle was co-founder of Autodesk, wrote the original AutoCAD himself, and then spent 16 years in stealth mode writing the most amazing piece of software for accelerating performance in highly parallel environments, and we use that in our work. Nick Hodges was president of Microsoft Technology Licensing. We filed a bunch of patents. Nick is in charge of all these patents. Ken Goldman, you've probably heard of, CFO of Yahoo, CFO of Siebel. Marcus Sachs, we pulled out of, we have a lot of connections with the government and with DoD and Intel groups through our past work. And Marcus was at Verizon as head of cyber. He was DHS as head of cyber, and at the NERC, which is protecting our grid. So I think you get the pattern here, which is that these people are all veterans. They all know exactly what they're doing, and they're the best in the world at doing it. Now, this is the place where I think the rubber meets the road. It's easy to make claims. You probably hear them every day. Prove it, right? Prove it. And so we thought a good way to prove it would be to go into bio first. Bio is the most competitive, the most difficult place you can go with a new compute system. And just to make it even more interesting, we used a thing called Metabrick. It was a data set for breast cancer victims that had been out in the public for 20 years. So I don't know how many, but make up a number. Thousands of people had been through this thing with, you know, with every data tool they had, trying to find secrets about breast cancer. And then we show up 20 years later, and in our first runs, guess what happens? So we are now proud to announce that we have been through 2 tiers of testing for 2 different cocktail candidates. And you can read what's on the screen here. We've passed on both of them. So we are now in the amazing position of, in our very first runs, our very first project, which was this project, we passed the national labs tests for biopsied cancer cells. We can kill the cells, we don't kill the healthy cells, and we're moving forward after 2 layers of those tests into mouse tests. If the mouse tests are negative, it's bad news. If it's positive, it's very, very, very good news. So I think you should read the disclaimer at the bottom of the slide. Lawyers wrote it for us. But here is the first proof, and it was proof to us too, that we aren't just hoping for the best. We actually were able to take something that had been out in public for a long time and find very important new things, test them biologically in vitro, and find out that they were real. That's what we do. Often, while we're doing one thing, we discover something else. The tools are so different and so powerful that this happens. I call these drive-by discoveries. So while we were working on what I just showed to you, we found something else, which is a diagnostic panel for breast cancer that was much more accurate and more effective than the current one they use. So the current one uses 50 different genes to test, and they have a certain high rate of accuracy. Well, our accuracy rate is higher, and we were able to do this with only 6 genes. So cheaper, faster, better. This kind of thing happens for us a lot. And as an example of a lot, the second thing that we did was we applied these tools to lung cancer. Now, keep in mind, imagine that you're on this journey with us. We aren't really specialists in any of these fields. We have people now who are excellent in bio, but when we first started out, we were mostly computer people. And yet we could do these runs and find things that had never been found before. And part of the excitement, and for me personally, is that we're visualizing these things as we go. So we're finding better and better ways of sharing with you what we're finding and sharing with our customers. In this case, you're seeing a picture from a video that we made of the actual genes related to lung cancer, and we coded these for pre-approved by the FDA for drugs or not, and how tightly bound they are in networks of activity. So normally, and this is surprising, I think it'll surprise you, when we did this, it turned out all the papers that had been published only addressed 1 gene or 2. Well, guess what? Cancer is more complex than that. And so is most everything, including Wall Street. So if you really needed to see the problem and its solution set, what patterns were involved in causing or correlating with something, you'd have to see a picture like this. And here you're seeing exactly that. This is a family of genes who express in some correlative way with lung cancer. This is one of about 8 things we now have in our bio pipeline. It's pretty amazing for a small team after just about a year's worth of effort. Another experience we had, and another way of correlating this with outside recognition, is this is a test we did with Larry Smarr, who's quite famous. Larry is the director of the Qualcomm Institute in San Diego, also called CalIT2. He was the founder of the National Supercomputing Association, and he was a co-founder of the personalized medicine movement. Larry had a problem. He had Crohn's disease, and he was trying to find correlations for the proteins in his gut microbiome that would be helpful in predicting this for other people. The permutations of that study were something like 10 to the 40th. In other words, there are about 20,000 species of bacteria and virus in your gut, and they all produce proteins. So how do you weigh that down? Take that imagined 10 to the 40th tower of calculation and bring that down to something useful. Well, in 10 days, we were able to do this and bring it down to 39 different proteins and then down to 9. And keep in mind, Larry has his own supercomputer at UCSD, and he was able to use the best tools around. I won't name them right now, but something out of Stanford and other places. And yet in 10 days, we could do what he hadn't been able to do in years, and show him those 9 proteins. And of those 9, show him that 4 or 5 of those all had shared attributes that could be causative in understanding Crohn's disease. And in doing that, we changed the path of his research. And he was working with a team he had brought into his own laboratory, which is the best team in the country, if not the world, working on microbiome. And they were part of this study with us. And so they were as surprised as Larry that in 10 days we could help them this quickly. Here's another very different question. Can you work in imaging? And the answer is, yeah, we can. So you may not know this, you may know this, but when kids get pneumonia, this is true worldwide, it's hard to discern, A, do they have it, and discern that in time, and then if they have it, is it caused by bacteria or is it caused by viruses? It's very hard, if not impossible, for a human being to look at x-rays and find that out. But of course, we can do that because we're using computer vision. So we looked at these things through our system and found 2 things. We were able first to say yes or no, that child does have that. And second of all, is it caused by or correlated with viral or bacterial? This hadn't been done before. It's something which in the emerging world is pretty important because the alternative is taking biopsies, sending them off to the lab, waiting for how long, sometimes too long, and you lose the kid. So far I've just talked about the bio side of things, and I don't want to understate that. Bio is the hardest, I think will always be the hardest. It probably brings the highest valuation to the company. We'll come back to that. It's the most exciting. The reason that our team went into it is because they have a lot of heart. They want to do things which are helpful, and they do that. So bio is a big deal to us. It may be someday we'll just spin out the bio part as its own division or its own company and really focus just on bio. While the rest of the time, here we go. So if the question is, Mark, prove that you actually can justify these claims you're making, is it really true that you can go into other fields as a team and achieve the same great results? And the answer is, yeah, you can. So here are examples now. We've made a lot of tech breakthroughs. Now we're making breakthroughs in the actual application of this technology to, here's a list right now. So aerospace, our very first commercial engagement was in aerospace. It's a manufacturing problem. So you don't want to have aerospace parts fail. What can you do? Well, using today's tools, it's tough. People are still having failures, as you know. Is it possible to learn more about manufacturing and sensors in manufacturing so that with larger amounts of data, more complex data, higher order dimensional data, which our tools can actually use, then you learn more. And by learning more, you can improve the efficiency of manufacturing. We have another potential client we're talking to now, also in aerospace, who's in defense. And their question is, well, we've tried to do this, we can't do it, can you do it? And it has to do, I can't go too deeply in it, but it has to do with a defense-related situation and a lot of sensors. Can we learn something that they can't learn from all of their data? And the answer, I think, is going to be absolutely we can. New materials. So here's something kind of exciting. It turns out that there is more than one way to make a new material. This new materials, by the way, is a pretty hot topic. And the normal way is you hire a metallurgist or a couple of chemists, and they have a hunch and they try something. Well, as you can guess from what we're talking about, there's another way to do this. What if you decided to use pattern recognition and pattern discovery? Now imagine that we take patterns from existing materials that have well-defined properties, thermal properties, conductivity properties, weight, elasticity, strength, and so on. And we look at the patterns of different chemical families to understand how to build new, until now, unknown materials that have those particular types of properties. So we're in the middle of building new materials right now. We've worked for about 6 months. We have 2 specialists out of the national labs who are vetting our work from a compute basis, and we're now about done with our side of this, so it's very exciting for us. We're turning this over to them, and then they will do what are called intensity density calculations, and that goes then to a company that'll build the new metal. So wow, you know, I mean, this is something which is a completely new way of designing materials, and I can't really overestimate or overstate what that is about. We are not just doing that in the sense of materials, but we're really approaching science by flipping the scientific method, and that is something quite new. So instead of starting with a hypothesis and then testing it, that's what I was taught in 5th grade, it's the opposite of that. There's no hypothesis, and we walk in and we just let the world talk to our system, bring out all the different patterns that are there, learn how to rank them, very important because there are often many of them. Having ranked them, make a model, and none of this involves our own bias or our own ignorance. And that's something that really is quite new. So, and that's really the explanation, a lot of it, behind why we're so successful at doing this. So another project, feedlot health. I don't know who's excited about this. I think it's exciting because it's part of the food chain. What matters here is we're working as a partner with the largest data set owner in North America for feedlot health. And what we've done is we've taught our system to look at cows which have died from different diseases, identify the top diseases, which they'd already done, and then teach the system to understand how to do necropsies when they're all done, so that we can very quickly understand what happened to that cow, reduce their costs in terms of veterinary costs, but more importantly, reduce the amount of antibiotics being used in replacement for this kind of thing. So that's our impact goal, is we want to have fewer antibiotics in the food chain, and to do it by doing it with this visualization technique. A different and very different approach here is something that Accenture brought to us as a challenge. And they said, look at the flight operations in America, all of them for a certain year. It was 2 years ago. And we said, okay. So we look it up, and sure enough, there's a public data set, 7 million flights roughly in that year. And what do you learn from looking at 7 million flights? So we dived in, and it turns out there wasn't enough data. Now, for those of you who are familiar with AI, you'll know that people try to restrict how much data there is in general, because the memory requirements blow up as you start getting more and more data sets. So in our work, it's the opposite. The memory not only does not blow up, but we want to have more and more data sets involved. And the result is we ended up going out and looking at probably 4 times as many data sets as the original set in terms of overall gigabytes, terabytes, and then putting that all together and then doing runs against that. And we found a completely new way to run air operations that would reduce flight delays and change how carriers plan their flights. This is really exciting. We're almost done with this now. We've just added another year's worth of data, and we'll be taking this to carriers and seeing if they want to save money, change how they fly airplanes as they return to the new normal. And I think that they'll love this. Industrial. So we are talking to the largest industrial companies in the world, not just in the US, but in Europe, and obvious places to work. One of them is additive manufacturing, or what people call 3D printing. It's a very important new thing. It's been held back by being a prototype story for a long time, but now it's becoming very important in manufacturing. There are a lot of problems, and the problems have to do with higher dimensional, complex data sets and not having the tools to properly address what those things are telling the owners. And so we can do that for them. And I think we'll have a big role to play in additive manufacturing. And then in terms of medical devices, the same thing as the aerospace partner I told you about. So 5 years trying to solve the problem of why do some medical devices fail and some don't. And we have a tool set better than theirs, and we'll come in and help them figure that out, and that'll be a good thing for both of us. And then finally, in finance, kind of an obvious place for us to look. One of the largest banks in the world came to us, asked if we could help, so we're talking to them, and we're in the middle of talking to 2 different insurance and reinsurance firms. So in summary, there isn't really anything that we can't do as far as I can tell. There are certain types of things we prefer not to do, but generally the system is robust and it is agnostic. It seems to work wherever you go. Here are some alliance partners, and we're proud of all of them. I think in some ways, I'm the most proud of the top one, the Fred Hutchinson Cancer Research Center. They're the top guys in the Northwest, and certainly one of the top, say, 3 or 4 in the world. And they early on agreed to have a master partnership for 10 years with Pattern Computer. That's pretty amazing. I'm not sure. I don't actually know. I don't think they have done that with any other startup. So it's an honor. And we are now completing the very first project that we worked on with them. And this is something worth crowing a little bit about. They are the administrator of a thing called the Gecko database, which is the largest colorectal data set in the world. It's got 7 different international consortia putting it together. The data is very messy for that reason. It took a while to prepare it. They were kind enough to share it with us under restricted conditions. We were able to run this in the cloud, which was one of those restrictions. So we had to work hard to figure out how to put our stuff into a protected cloud instance of theirs. And the runs are happening now. I have to be careful here. We know we have strong signal, and we are highly confident that we will do much better than the Hutch has done. We'll see how that works. In terms of accuracy, well, there's a reason for that. When they did their run against this data set, and I'll describe it for you in a minute, they were only able to use a small part of it. So this data set is huge. It's 150,000 patients, and for each patient, 39 million features. Think of the permutations if you're looking at that for correlations between those 2 columns and rows groups. It's uncountable. So what they did, of course, was they cut that back. They went after 10,000 of those columns and then later added 6 more. Well, as you recall, I said 39 million. So we're running the entire 39 million against the entire 150,000. And even so, we have to do that in pieces, but we're doing all of it. And that will, I think, be the largest data run probably ever done outside of the defense world. So it's a very, very big accomplishment for us. I hope for them too. And of course, the point is save lives. So when we're done with this, fingers crossed, we will have a higher success rate than anyone has had to date in leading indicators to be used for predicting colorectal cancer, and of course, all those things that flow from that kind of knowledge. So you're going to hear me come back to this in a minute, but having the knowledge about how these systems learn is what's often called explainable AI, and is generally almost completely unavailable to other people. We are about to publish a white paper, not a true paper, a peer-reviewed paper, with scientists and co-authors from all the other national laboratories on the issue of explainable AI in anticipation of some additional work we're going to announce later. Our business model is simple and straightforward. We want to have an engagement fee to cover our costs in doing setup. We want to have be paid for our time while we're working with our clients at a reasonable level, because these are their biggest problems. And so that's in the millions. And then we want to have not a big share, a small share of the results, because we know that they're valuable. This is a quick picture of our fundraising story. And as you can see, it's pretty cool. And there's a reason why I'm sharing this with you. So here's what we've done so far. And the interesting thing to investors, in my opinion, is that this round, which has been extremely well received, we've already doubled it, it was set at a pre-valuation of 50 million. That was before any of the tests came back positive from Berkeley Laboratory. So if you asked, if we have one successful candidate out of the two that we've gotten, these are all patented or patent applied for, what's that worth? The valuation of the company at a pre of 50 is about the low end of what that's worth for one successful candidate. So clearly, people who've come into this round so far are getting the benefit of us not having had the results of those tests yet. When we close this round, we will then be valued as though, which we have done, past those tests. So it makes for an interesting story if you're an investor. And I'm not going to throw any other numbers around, but we can look at PitchBook and figure out what should the company be worth if you have two candidates going into mouse testing and so on. So here are the terms. It's a preferred. All the rounds are the same. We try to be very fair to our investors. We actually have an investor relations person who works full-time on investor contentment. It was a pre-money valuation of 50 million. 16.6 raised. We have about $1 million something left in that round. Love to have you join us if you wish. And the purpose is extend the runway and break even, both of which are within the next year. And this is what I told you I'd come back to, and then we'll go to questions and answers, I think. This is a picture of a neural network, and it explains the black box problem visually by showing you what can't be learned today, but what's important to learn. So here's an example of why it matters. And I'll say this in two different ways. Our systems architecture includes a neural network, but it is a rather small part of a very much larger architecture, about 50 different pieces to it. And the system itself has two discovery engines in it. And one of those discovery engines, which is, I think, the more successful of the two, although they work together, is not a neural network. And so we already are able to explain through that system, we call it Leonard Island, how things work. Why did we get what we get? What was the system seeing in order to get that result? But with the problem with neural networks, which again, anyone that says AI is probably talking about neural networks, is that they can't see inside that black box. Well, I think we're going to be able to do that. So I won't talk more about that, but it's a huge thing. And here's why it's big. It's not just a technical question. In Europe, for instance, there's a thing called GDPR, which is an existing regulation that says that when a bank declines any company that uses AI and then affects a customer. So if a bank declines a loan, for instance, why did that loan get declined? And if the bank is unable to tell the customer why, they're liable by law. So all of Europe right now is living under this law, which is not enforceable. They need to have the ability to see this stuff. And of course, we'd love to help them do it. So that's kind of my last little teaser. We'll tell you more about that as we write papers about it and announce final things a little later this year. So that's our story. It's an exciting journey. Every day we find new discoveries, and it's really hard to describe. You know, I think it would be like Leeuwenhoek, or if you had first discovered the microscope and you start seeing all these little bugs or microbes, we're able to see things that haven't been seen before in any particular field, and that is the most exciting journey I've ever been on. So I think, Lindsay, maybe we could see if there are questions and go from there.
Great, Mark. Thank you so much. And yes, we do have some questions pulling through. Again, I want to encourage everyone to use your questions chat option to send over your questions so we can have Mark answer them. So John Anderson has a question. Today you operate as a solution discovery company. Is there consideration given to selling or licensing your platform to others?
Kind of, John. So we are very interested in licensing, and we have ways of licensing the models that we make and licensing the discoveries that we make. We're not particularly interested in anyone getting hold of our source code, as you can guess. So that is our secret sauce, and that will be preserved for the shareholders. But there are a lot of ways for us to work with partners and customers in ways which include both those things. And we even have gone to the degree, we've just finished a 3-year project called Cooksey, where we've made a special board that can go into a PC box, and we can give that to a customer or to a partner. And so imagine that you're an oncologist in an office, and we've worked on breast cancer, for instance, and we have figured out how to do quick genomic analysis correlations for that person, that woman who came into the office right there. Why wait 3 days or 5 days or 3 weeks, whatever, do it right there. And so we can build that model, which takes a huge compute in the beginning, reduce that down to something you can put onto that board, give you the board if you're the oncologist, and run that in your office real time with that person. So in that sense, we're licensing the model to that oncologist or to that hospital. We could also license access. We can use that same terminal, so you could come into our data center under secure conditions and do your own runs. So that's another way of sharing. Everything except sharing source code. We're not doing that.
Great, thank you. Let's see here. Robert, he's asking, are there applications in cybersecurity, decryption, oil and gas?
Yeah, well, yes, and yes. So in cybersecurity, we haven't done the cyber one yet, but of course, as I mentioned, we have a lot of people like our CSO who are cyber experts. So I'm pretty comfortable about this. And there are, I don't know if Robert is an expert in cyber, but there are a lot of different ways of going after security. And one of the more successful ones is called heuristics. And you're looking for changes, patterns of use, patterns of change in a network, because you basically assume that the enemy is going to get in. Firewalls are kind of important old hat that don't work very well. So when you assume they're going to get in, what you want to do is shut it down as fast as possible, exclude them as fast as possible, contain damage as fast as possible. And that's kind of the state of the art in cyber. And of course, something which can see patterns more clearly would be an excellent tool for doing that. So I think the answer is going to be yes for cyber. In oil and gas, we've already been approached by some of the largest companies in the world in oil and gas. So we know they're interested, and it makes sense because they look at patterns of data in exploration that pay off for them. So we think that we can do a better job than their tools have done so far, and we're in conversations with them now. What was the third one, Lindsay?
Those were the two that he asked about. Yep, perfect. Let's see here. Can you please go through a short form P&L, current YE 2020, and where you think you'll be end of 2021?
Sure. So the P&L part's easy because we don't have any revenues for the last year. We had our first 2 commercial engagements in Q4, so 0 revenues. This year, we think will be our break-even year, so that's exciting for us. We have a run rate that costs us between $3.5 and $5 million a year at current run rate, and we have a good bank balance right now. We've had the same bank balance for almost 4 years. So we've had an ongoing support from our investment group. We're very proud of that. And what else? As you've seen, I think from this conversation, the way we make money is by having it's not a B2C, it's a B2B, and it's not by having thousands of customers, by having a few good customers. So we're currently working with, I would say, 6 to 10. We'd like to see 2 to 4 of those come through, maybe 5 for the year. And if that happens, we'll be in great shape. We'll make money.
Great. Also, how many of the current engagements have paid for service? Please provide ballpark amounts versus receiving for free.
Right. So as you could see, we started doing things to prove the case that we were different and better, and we didn't charge anyone for those things. So some of those buyout things I showed you were pro bono. Again, in Q4, we began our first commercial engagements. The first one was with the aerospace company that I mentioned. They just doubled phase 1. There are 3 phases to that deal. So these usually will start out with in the hundreds of thousands of dollars, which is true in that case. And then phase 2 will be in the millions of dollars, and so will the others. So we're happy about being able to do that. In the second deal that we did, which was again last year, it was a very different kind of thing where we were working with the feedlot company, and we've signed an open-ended partnership agreement with them where we split benefits. And so we're going to have shares that we create out of the money they save. And so it's a different kind of deal, and it can grow and grow and grow. We think it will also expand into other animal medicine abilities for us. So we're starting to look at that. So it was less about front loading that. It was a lot more about getting a bigger share later. And then we're currently talking to, one of the things I'm finding exciting is a very large aerospace firm that has a lot of defense work. And it would seem to me that they're interested both in paying us out of their R&D budget and out of their equity budget. So we may have a strategic investor there that's paying us in 2 different ways, but that would be in the millions of dollars. So we're comfortable that we're able to find big enough problems and from big enough companies that we can meet our plan.
Fantastic. And Brian Moss is asking if you can talk about revenue and costs today. What is the burn rate and what are revenue projections? Some of these have maybe already been answered a little bit, but we want to make sure we get everyone's questions.
Yeah. So I did mention the burn rate already. The revenue projections for this year should take us into break even. So from what I just told you before, that means we want to see 5 million plus this year. And if we do that, we'll be making money. So this is not the big year for us. This is the big year in terms of breaking out of being proving the tech and into being commercially engaged. And next year 2021 will be a big year for us in terms of money.
Great. Next question. Are you ever in a competitive engagement with other AI type companies when pitching? If so, can you comment on win rate statistics?
Yeah, it's a matter of fact, that's a great question. We have had to go through the learning process like all startups of how do you talk to your customers. And here's what we learned. Our greatest competitors weren't outside groups like us, they were inside groups. And so when we come to and I want to say this carefully, we've yet to not be able to engage with anybody we chose. And now we're happy to have people coming to us. So that's good. That's a good test. So that, that's 100% is that the answer to that question. But when we engage, there were gatekeepers that were thrown at us. So as you can imagine, you go to a Fortune 50 company and they say, oh, sure, we'll talk to you. Here are our AI scientists. Talk to them first and tell them whatever they want to know. Well, then they want to know all your secret sauce. And you don't know why. Maybe they just want to take it and do it themselves. I don't know. But of course, we wouldn't share that. So you get into this kind of loggerhead position, and we learned, you know what? We don't want to talk to those guys right now. We want to talk to the guys who have the problems in your company. And then we'll talk to the AI guys. And that turned everything around. So now, as soon as we approach a new firm or they approach us, we say, great, let's have a conversation. You bring us your biggest problem and the people who own that problem, and let's go, and we'll show you what we can do. And then we'll talk to your AI guys. And that's changed everything. So again, the rates are high. We don't really have any fails. Another way to say this is we've not encountered a problem yet that we couldn't solve, with one exception. There was a very famous person who brought us a data set in medicine of all healthy people. They're all like 20 to 40-year-old, mostly guys from the tech world. And they said, look and see what you can find. Well, there was nothing to find. They were healthy. So that was a complete bust. But there wasn't a request. It wasn't really a problem. The guy who owned the data set didn't have a problem. He was just sharing data. So we want to find people who have a problem, and we want to make sure that the answer or the correlatives are in that data set. Otherwise, we can't help them out. But if that's true, we've yet to find any data set that we can't work on and find better answers than they found. So it's 100%. Big number. Almost embarrassing.
Fantastic, great, thank you. And now, Mark, can you kind of elaborate on what your most exciting discovery has been so far?
Yeah, they're all exciting, you know, I like them all. I think the breast cancer discovery, and probably because it was our first thing, but you know, if everyone's probably been through startups, but if I've been through a bunch of them, but if you're doing something which is essentially impossible, I mean, we set out to do this, and the chances of it working were low. You know, I mean, really, you're going to create a new compute system after everybody else has showed up, Cray and all these guys, and you're going to show up and do something new? Really? You know, show me, right? And so the chances of that working were low. And then when we did our first thing with breast cancer, and it was a public data set, everybody had already been through that thing with all these tools, craze, whatever, and then we could find something that would kill cancer cells, and not just any cancer, the most aggressive cancer cells in breast cancer, kill those cells and not kill healthy cells in our very first project.
That's great. Let's see here. Can you give us a little bit more detail on what the difference between pattern recognition is versus pattern discovery?
Yeah, that's a great question too. So everyone, I think, knows what pattern recognition is. It's kind of how all of our minds work. And it's certainly how all neural networks work. The problem is it tends to give you very incremental improvements and declining over time. Pattern discovery is different because pattern recognition assumes a hypothesis. For example, you're Google and you want to sell more gym shoes to teenage girls. And so you're training the set on what is a teenage girl, what is she buying right now, what color does she like, red or blue, all that stuff. And so, you know, the first time you get a big jump, and then the second time you get a 10%, then you get a 5, then you get a 3% jump. Pretty soon you're getting a fraction of a percent jump. You're kind of done there. And what did you learn? Well, not much. You didn't, that's not a discovery really. That's just an incremental learning about something you kind of knew already. But what if you learned something you had no idea about? So back to cancer for a minute. What if there are genes that were involved in a cancer that you had no idea about? Well, that's cool. That's a discovery. So you get that by having no hypothesis and just asking for all of these men or women who went through the experience of having this cancer, what were their genomes and what were the gene expressions of those genes and what was the correlation, without you making any statement whatsoever. And then you get the information, you go, wow, some of that stuff I knew and some of that I had no idea about. Well, those things you had no idea about are discoveries.
Thank you so much.
Yeah.
Let's see, next question. Assuming this year's revenues target is met, what kind of capital would you need to scale to next year? And would you anticipate changing the sales model, you know, using inside sales potentially versus what you're doing now?
Yeah, these are all great questions. So we'd like to get our runway out further. We think that by adding something like, this is a little complicated, between 3.5 and 5 million, some of which is already signed for legally, by the way, that'll get us there. Now, the question that includes the part about growing, and we definitely have plans where we can accelerate things. So we don't see any showstoppers right now, either technically or in terms of what we're doing for customers, where we couldn't hit the gas. And we all want to do that. So once we've got that base thing, filled in terms of investment, we can take more money and do a lot more good. So in terms of real numbers, we could double or triple that amount of money we're talking about and make great use of it.
Perfect. Let's see. A little bit of role play here. If I were a company, can you kind of explain and paint a picture of what partnership would look like?
Sure. So you've seen the model that we just showed. I've talked about some of these already. I usually try to use an example. Let's say that you are a big industrial company from Europe, and you have a big problem in manufacturing, and it's a really big problem. There's liability attached to it, and it costs you money, and it means that you're not as strong in your competitive situation as you could be. Can we help? And the answer is, yeah, we can help you with that. So what's that worth to you? Well, that may be worth hundreds of millions or more. And so what do? And you give us a shot at your data, so we don't need to see the entire thing. Give us a data set. We'll show you, and this is fun. So we'll show you that we can find what your guys internally cannot find. And when I say show, I really mean show. So something I didn't mention during the presentation is we're about to announce a new product, internal product, called the Dimensional Navigator, which for the first time allows people to see in very high dimensions. All of our competitors use three-dimensional portrayals. We did something really cool. There's a woman inside our team who did this, and it's pretty mind-blowing. And so we can use either a screen or VR and take you into a very high dimensional situation, show you what we found, right? And fly you through your own data, show you what you know, show you what you don't know, and then talk about how to go after it. I think this is like, wow, this is space age stuff. So, eat your heart out, Elon. So this is going to be a really fun way of looking at problems and solutions that wasn't available until now.
Thank you. And now it looks like these are going to be our last couple questions so far, but if anyone has anything else they would like to ask, again, using your chat option, we do have a little bit more time left, but I'll kind of clump these questions together. Could you give us a little bit more depth on what is the commercial value and what is your value history over time?
So
valuation, excuse me.
Sure, yeah. So our value history doesn't exist yet because we didn't start looking for commercial engagements until Q4 of last year. Our future commercial value, if you mean in terms of the value of the company, I guess that's what you mean, someone means. We have our own plans, of course. You've seen the current hockey stick. That's going to be continuing. And it's not hard for us to make that statement, or for me, because we already have these first two discoveries in the bag, so to speak. In other words, we've proven them in organoid tests, and they're now going into live animal tests. So we already have an increased valuation from having been through that for two different sets of cocktails, both of which have patents applied for. And we've just this week applied for more patents. So we file as often as we can. So these things are well protected for investors. And the idea here, which is a little hard for folks to get their arms around, is normally a normal experience, in my opinion, of a biotech firm, as an example, but it could also be an industrial firm, is that a scientist gets an idea, they try the idea out, it takes a long time, it takes years of research, they figure it out, then it has to go through all the testing at the FDA and on and on and on. So a single company story might be a 5 or 10 year story. With luck, it's a little quicker. We could find things with this kind of system often. And part of what we're trying to learn internally is how often. So once we have a data set up to go, what can we learn from that? Well, we often get tens, hundreds, or thousands of patterns back from our initial searches. What do you do with that? Well, do you throw them away? No. Okay, are they all valuable? Probably not. Are they all meaningful? Yeah, I think. So what do they mean, and who do they mean it to, and how do you align customer needs with all those discoveries? We're not sure yet, but we are certainly sure that working with customer A, we can do that with that customer. Now, how do we build a business model which not only does that, that's normal, but what's the abnormal part here? That's the fun part. The abnormal part is we've got a whole box of these discoveries suddenly every time we do runs. We need to figure out, can we get partners going who can take a higher load off of us for doing, for instance, animal testing or for doing biotesting? Can we have somebody who's in the industrial world help us broker discoveries across a wider field of customers because we've already made the discoveries? So we have a really interesting problem. We can make discoveries quite quickly, and we need to be able to do something different in the world of business than what's been done before. So we can do the old thing really well, I think. Talk to the customer, solve their problem. But now we have a new problem, which is we're going to make some very important discoveries in lots of areas. We'll be sitting owning those and wanting to license them out or sell them. And we need to understand how, while we scale up, how do we scale up that distribution system to other people?
Wonderful. What other types of capital providers are you speaking with? VC, PE, etc. And can you provide your thoughts as to why or why not?
Well, sure. I think we're all laughing right now. So we have been solely funded by angels. Our original thought was to do the usual thing, which was to be funded by families and friends, then angels, and then VCs. We had difficulty engaging with VCs initially, and I can't tell you exactly why. I think I have some theories about it, but we had the same exact experience that I just described with customers. In other words, they would put someone forward, some of them are quite famous VCs, and they say, well, how do you do what you do? We say, well, we'll tell you most of this. We're not going to tell you our secret sauce. You guys are on the board of other competing companies, so we're going to tell you everything. And they'd say, oh, and then we never get a call back. It's hard for VCs in general to do technical things, in my experience. It's not impossible, but it's hard for them. What we're doing is extremely technical. In some ways, just like Elon being the best guy in the world of rockets, we might be some of the best guys in the world at this. Maybe we are the best. So it's hard for them to get their arms around it. And therefore, just as with customers, we need to find ways of talking about the problems and how to solve problems. That's where we shine. So we shine on the tech side, but we can't tell them exactly what we're doing. We've gone to it, as you've seen by who we hired as our CSO. We know that what we're doing is a target worldwide. We have competitors who want it. We have other countries that have made it their top target for theft. We've got to be very careful to maintain that internally. So that has led us down a path where we think the next money for us, we'll continue to get money from our existing investors, which has been wonderful. We've got a lot of folks who've come in 2 or 3 times. We'll get new investors who are angels or family office, but we're going to move, I think, straight from that into strategics, meaning corporations that value what we're doing, like the one that I mentioned earlier, the aerospace guys. So my guess is we'll have major partners, not millions of them, 3, 4, 5 over time, that want to invest because we're helping them in their world, and that will be our next leg up, and that will get us into enough money to go where we need to go.
Wonderful. Esther would like to know who is on the board.
Right. So the board right now is small, and we're looking for more people. So I don't know which Esther, could be Esther, my friend Esther Dyson, but we are kind of on the hunt right now. I'm on the board, and Rick Lefevre is on the board, and John Pitotti. And John came to us through our S&S company, and John is the ambassador for angels. So he was probably the top angel investor in our network, and he had founded the Santa Barbara Angels. So at that time we were looking for angels, and John was the perfect choice. We try to pick people for the board who represent our next steps, you know. So, and then after that, it was going to be VCs, we thought. So Rick Lefebvre ran the largest VC firm in the Northwest, a longtime friend of mine. He was head of technology at Apple, just done a lot of technical things, really great guy. So those are the three people right now. And we're looking to add a couple more. We'd like to go from 3 to 5. I think we'd like to get a woman on board, and you know, of course, somebody who's qualified. And we probably would like to have that person be either a bio-related person or something in large corporations, where, you know, help us go that direction. But we're definitely open to finding 2 more.
Wonderful. And this is probably going to be our last question today, but it's asking, and I know we kind of hit on this a little bit, but can you talk about competitors and your specific competitive advantages? Who has comparable technologies?
So I don't think anyone does. That'll sound stupid, but we haven't encountered anybody who does. But comparable in a sense. So if you said the leaders right now, we see companies like Palantir or Ayazdi. We don't think much of Watson. I don't think IBM thinks much of Watson anymore. So I don't know if that's fair, but we never did. But those are comparable, you know, tech stuff. And I mentioned this in one of the stories I was telling. When we were working with Larry Smarr on his Crohn's disease question, that thing where we found out of 10 to the 40th permutations, we got it down to 9 proteins. Well, Larry had been working with a company called Ayazdi with their tools. It's a very well-known tool, and he'd been using that on his supercomputer for years. So in 10 days, not on a supercomputer, on our own little data center, we were able to do much more than he could do. So I think that, you know, having those experiences tends to indicate to us that we really are able to do things that the experts with big iron can't do yet.
Great, thank you so much. And I know that on behalf of everyone at Family Office Networks, we really want to thank Mark Anderson from Pattern Computer for joining us today. To all of our attendees, thank you so much for the fabulous questions. I will be following up with all of you individually, so if there's anything else that you would like to ask Mark, we can make sure that you get in contact with him. We hope that you have a great day, and we look forward to speaking with you soon. Thank you.
Thanks, Lindsay.
Thanks, Mark. Have a great one.
Bye-bye.